So what is a fashion MNIST basically? So this is the second case, okay, example. I'm going to through quick this one because you know already the first one. So just now, the XOR, you are working with numerical 0 and 1, 1 and 0. Fashion MNIST, you are working with the images, okay? So these are more related to your assignment. And I want you to, after this, I want you to take a serious look on this example, fashion MNIST. Okay, the XOR is just to give you some knowledge about what is a neural network to be designed, but the pattern will be the same, you know. But this one is more important. I want you to get through this use case properly, get understand, because this is related to your assignment 1. Okay, so basically the task is fashion MNIST. Basically the task is clothing recognition system. Okay, so once again the same thing, face recognition system, object recognition system. This is clothing recognition system. So basically what does it mean is you got a system that can recognize a picture of clothes. If you given a cloth of t-shirt, the model gonna say this is t-shirt. If you put image trousers, the system will be able to say this is a picture of trousers. That is a clothing recognition system. When you said about face recognition system, when I given a face, this is the face of human. Okay, this is a face of human person. And if you take face recognition system, simply you're gonna recognize this is the face of person. That's it. If you put attendant recognition system, and then you put face, he's gonna say this is Putra, person named Putra, something like that. Okay, so remember that. When we said face recognition system, we just simply can recognize it is a face of human. When you give a picture, they're going to recognize, oh, this is a face of human, this is human face, this is human face, this is human face, but it doesn't know what is name. There's a face recognition system. To be particularly know the name, you can set attendant recognition system. Attendant system, something like that, okay? And in that one, you have detect the face. One, you know, detect the face, they can compare the face to the database, what is the name of the person. That's a attendant recognition system, okay? You see the difference there? The important is the problem statement. So in this case, clothing recognition system basically is to recognize the clothing. Given the picture of trousers, so the system can really detect, predict this is a t-shirt. And you given a trousers, the system be able to say this is a trousers and so on. So this is a task we're going to develop. So, all right, as usual, these are the steps that you're going to do, understanding the problem. Okay, so your problem, basically, your input is the image. In this case, this is the image of jumper. So, because this is a clothing recognition system. So this is the picture of images, clothing, in term of in form of image. All right, image now. We're talking about image now. So you can put here is nasi lemak. You can put here nasi dagang and so on. Picture of nasi dagang. But here is our problem statement now is clothing recognition system. So this is the example of image you're gonna have. The image is quite immature, you know. It's too good if you take a picture like this, okay? But it is for example. So the pattern of the image is gonna be like this, okay? So if you so that is a problem statement. This problem statement, the image that we're gonna give to the model is pattern like this. Okay, all the image are like this. Okay, so okay, like this, image like this, image like this, image like this can be input to the system. And if you put like this, system will be able to detect because this is different data set. This is different data set. This is different data set. Yes, this is okay. If you put this image into the system can be able to recognize. Simply because you need to understand the problem statement, what kind of images here. Okay, so computer software can recognize the jumper to develop a deep learning model that intelligent. Okay, the same thing, we're going to develop the model prediction. And this is when you need to resize the input. Basically, we will see later, and we're going to develop the model. And now we got a 10 label here. T-shirt, trousers, pullover, dresses, coat, sandal, shirt, sneaker, bags, and ankle. So you got 10 label here. Clothing recognition system, the system that be able to recognize the clothes of T-shirt, trousers, pullover, dress, coat, sandal, shirt, sneaker, bags, and ankle boot. Other than this, they cannot recognize. Okay, so we're gonna have a neural network model here to design our task. The input will be the image. Okay, this is one of the image. And if you see here, it's black and white simply because you don't worry about the color. Color is not important. The important is the shape. As long you can make sure the shape is there, and it can learn. And like this, you can learn that this is T-shirt. Okay, T-shirt. Because he doesn't care about the color, he just care about the shape. So you can resize the image toward to the stage that it can be recognized a bit is okay. And it is important to resize the image into black and white simply because to make the run faster. When you use this, it's still okay. All right, still okay, still can do, but it is too big and need processing power. And if you have like this, they are perform the same thing. Better take this one because it's more suitable. Color is not important here, okay? And all right, this is the image data set, okay? So in this case, if you go to Kaggle, Kaggle is where you got a lot of data set you can, okay? So if I say, okay, now you got have this one, okay? There I got two, Zalando, okay, let's take this one, okay? So this is the image, and then this is the data set. So we need to understand the data set basically, okay? When you do the thing, you need to understand the data set, background of fashion MNIST data set that we are going to download and we're gonna run it. So data set basically has 65,000 images. The data set is contain about 65,000 images. And 55,000 images are set for training and 10,000 images are set for testing. And the image, simply like this, the picture, okay? Each of the image is 28 by 28 grayscale image. So this is 28 by 28, this is 28 by 28, this is 28 by 28, all of this, okay? Since this is the image that it's gonna learn, so when we I said just now, when we do the image like this, okay, so this can be recognized, but this one, yeah, probably they can predict, but not really. The model not learn enough because the model now gonna learn a data set simply in this form. So this is an image data set. So they're gonna learn like kind of this form, image. Okay? And when you having a image like this, they won't be able to recognize. They can name it, but probably it's wrong. This is not the way they learn. This is okay. They can learn similar data set And this is definitely cannot, this is definitely cannot, this is definitely cannot, this is definitely cannot, because too many t-shirt. And here you need to crop here, okay, crop here, then he can learn, because the way we train them, okay, that's the most important thing. So basically the data is about 65,000 images, and you got training there, and you got label is 10 classes. The classes is t-shirt, trousers, pullover, dresses, coat, sandal, shirt, sneaker, bags, and ankle boot. So this is 10. So you can download the dataset basically from here. Oh, you get 70,000. So these are images, okay? Images. But how did it store the images? All right. So you can have here basically, and it store in pixel. Okay. So you got here is the image number 1. Here is image number 1. Pixel number 1 is 0. Pixel number 2 is 0. Pixel until 28 by 28. So 244. You got 244 column. Okay. 28 by 28. Berapa? 28 times 28. Can you calculate? You got 784. So it's supposed to be have 784 column basically. Okay. All right, and you're gonna store in pixel. Okay. All right. So let's see this one. Okay, this example, and you can download from there. Dataset content for the sample. Okay, you got. So basically, in my opinion, you got 10. You got each t-shirt will be 5.5K. This is 1.5K. All together will be 55,000. Okay, 5.5 times 10. 5.5K times 10, so you got 55,000. So in this case, it's balanced. Okay, it's a good data set. You got a balanced learning. Okay, but not necessarily. This is the best thing because they can learn thoroughly. Not necessarily the same amount. You know, it depends. Okay, if pullover seem very difficult, you can be minimized and easy to recognize. You can have lower things, lower numbers of images. Okay, and this is the way they store it. Okay, you got 10 classes, 0 and 9. So this is label. So basically, when you open this one, this is the label. This is the label. Okay, so you got 9 label here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first row is label 0. Something got to do with t-shirt. This is label number 1. Supposed to be jumpers. 2 supposed to be something. 3 supposed to be something. 4 something. 5 something. 6 something. 7, 8, 9, 10. So you got all 10 label. Okay. Here you got 10 label. Okay. So this is the content of the first pixel. Even if it's image, we take the input as a pixel. Okay, remember that. Okay. Because you got 28 by 28. If you got 28 by 28, means 700, and you got this basically. So your data set basically has 55,000 row and 785 columns. Okay. 785 simply because this is you got you have 28 by 28. So 28 times 28 is equal to 784 pixel. 28 column and 28 row. So you have time 28 times 28 will become 784 pixel for one image. Okay, for one image. So therefore, if you got 55,000 row, mean that you got 55,000 images, and each row has 785 column to represent pixel 1 until pixel 0 until pixel 784. And then plus the label at the end here, at the beginning or at the end. All right, and so this is how you download the things basically, and where is it just now? This is one. This is keras. This is question minutes. Okay, so this one. Okay, so basically it's you can run on your own. Okay, you can run on your own. So if I run this, what version is this? Okay, and 2.8. Let's see. Still connecting. Okay, that's the problem of Google Cloud, okay? Collaborator. Very slow. 6.8. So we need to run the whole thing, the same thing, the same thing. All right, look at the slide again. All right, this is how you input the data. And okay, so this is how you input the data basically. And so this is basically, we just print it on the screen to understand and exploring the data. Okay. And so this is, when you display the image, it's simply like this. So the output gonna be images shape 55,104. Okay. When you run this, okay, shape training, when you run this, basically you're gonna have this one. Okay. You got a 555,000 row and 784 column training set. And training set label, you got 500, the same amount, but you got label. Since we got 10 label. And the test image still the same, which is only 10,000, and you got the same row, same column, 784 pixel. And the test set also the same, because you got only 10 label, and then you got only 10,000 images. So this is put in metric, okay? 10,000 times 784. So this is a metric. Okay, so this is the picture has been resized into 28 by 28. So I think this one model are sufficient enough to learn that this is a trousers. And with this picture, the more able to learn which is a bag. If you resize again, probably it won't recognize. I think this is the best photo that model can learn. If you put more color, more quality, it's still okay, but it's just take some time. The performance still the same. Okay, and let's look on this. Okay, restart on time. Okay, and you can now is okay. Now finish. You're gonna input all the data, import all necessary thing, and this I copy from the internet how to download the data. You can download it from Kaggle. I downloaded it from this website. And one hot through, this is encoding about label to set 1, 2, 3, 0, 1, 2, 3 until 9. Okay, I think this is just follow the thing. I think fashion minutes is So I'm gonna set this. Okay, and so this is, they try download it. Okay, they try download it, and this is what you got. Okay, you got images, shape. So these are the same, this one. Okay, the same, this one. Okay, and if you try print it, okay, we have this, we try to print it. Image number 58, we reshape 28 back to the image. Okay, the image are stored in pixel, remember? So we're gonna reform into image like this. Reshape 28 by 28 and into gray things. Okay, so you're gonna have picture like this. So all the images are simply like this because you just reshape into 28 by 28 back again to the image. But it store pixel. It store in the database is a pixel like this. And all right. So this is the hard way. Okay. This is the hard way I recognize the model. So basically, when you do, I'm using a TensorFlow. Okay. To make simpler, you can use keras, but I'm using a TensorFlow. So you got 10 labels. So this one hot through encoding simply because you're gonna 1, 2, 3, 4, 5, 6, 7. You're gonna transform into some target value. Okay, into this form. So that's mean one hot encoding true. So it change like this. So it will be used during the training. We not use 0, 1, 2, 3, 4, 5. We use this. All right, and this is the same thing. Okay. These are this one, the above. Okay. And this one, the same thing. Okay. So this is just understanding the image. It is important you understanding the image, the data set before you do the thing. And this is just to, without this is okay, we understand, but this is just to show you, we can reshape back the pixel into image by having take the number 58 and reshape into 28, 28. So they understand that this is reshape to image. But the original data will be in pixel, 784 pixel. I mean, like this, okay? They store like this, not as an image. All right, and okay, so this is the model. Actually, what I have in mind is I'm gonna use the 28 by 28, and I'm gonna choose 3 layers. The first layer I put 256 neuron. The second layer I'm gonna put 265 6 neuron. And the third layer, I'm going to use 10 neuron. Okay, and I choose ReLU as active function for layer 1 and layer 2. And softmax at the end. Basically, at the output, you use softmax. And then I use Adam optimizer and I got 10 label. So this is the most important part. Okay. So basically, what you're going to do have like this. Okay. So this is important to understand the pattern. You got image basically like this, 28 by 28. But when you input, you're going to have until 784. So this is pixel. You insert the image as a pixel, all pixel from here until here. So this is the pixel number 1. This is pixel number 784, 85, 84. Because you start from 1. If you start from 0, this is 783. Okay. So you put as a pixel. Remember that. You put as a pixel. So you have to placeholder about 784 because you got 784 pixel to put in. Just now the OR you got only two input, 0 and 1 or 1 and 0. Now you got input about 784 pixel. The whole pixel at once. You have to input at once, so you have need 784. And you're going to also need a placeholder for label. Then you need 10 label there. All right. This is using TensorFlow. Okay. And so basically like this. Okay. So label here, this one. So you got label here. So this is 0, 0, 1, 1, 1, 1, 1, 1. This basically, remember this? This one. Okay. So the way you store there, basically just like this. Okay. They're going to understand like this. So we're going to put this, is this t-shirt. At the same time, we let them know that this is t-shirt. This is a label of t-shirt. Okay. So the first note here, you got 284. Then simply you got here 784. Layer 1, you got 256. Remember I said the first layer is about 256 neuron. So basically, okay, how many weight are there here? Anyone, please? How many weight? I think the last question. How many weight are there? How many weight?
65,000.
How do you get it?
The layer 1 and layer 2 multiply.
Can
The
you
number of
tell
nodes.
the number? Tell the number what to multiply?
256 multiplied by 256.
Yes, thank you, Kambing. Everyone got it or not? Come on. You got too many weight there. Okay. This is small, this neural network is small. 256 neuron, 2 layer is small. This considered small. Baby lagi, okay? And the first layer you got 784 times 256, which is equal to 2000 weight. You got 2000 weight here. And then you got 2000 weight here. And then you got 2000 weight here. So at the end of the day, you got about 600 weights. Okay? 600 weight to be assigned a random value. And then you do propagation. It's a long story, back and forward, so on. Okay? I think this is apply the same with XOR. It just simply I use here pixel. XOR is 0 and 1, only 2 input. Here you got 784 input. The rest is the same like XOR. Okay? And this is the way how you got many layer. Just now what I'm trying to do. Alright? So the first layer and this one, 784 times 256 weight. You got 256 bias. This is the second layer. The second layer you got 256 times 256. For the second layer you got bias 256. So this is the output. You got 256 times 10, which is 256 times tens weight here. Okay, and the same like that. Okay, bias you got 10 B3, or they put a bias at the output. Okay, it's okay. You can put bias. If you don't put bias, just delete this one. You don't have this. Okay, and all the same. Now WX plus B. This is for the 1 and B1. Then the output Z1 will be do the activation function. A1 gonna be again to the second bias and weight, WX plus B. And the result is Z2. Z2 you put activation function there on ReLU. At the end of the day, this is the output. WX plus B. Okay, B3 is 10 basically. There, 10. Then you got Z3. So return Z3. So Z3 will be again the target value minus the label. Okay. Z3. Okay. All the same like SAW. The same. Okay. All the same. Once you understand the XOR operation, this you can easily understand simply because you just change the input. and you still can use the same keras. The keras just simply like that. Okay. All right. So you have simply like this. How many? Just 1, 2, 3, 4. This is for the model. Neural network model, you just need 4 line of code. Then training, you just need 2 line of code. Let the optimizer run and let the train. And test, you just need only 1 line code. And prediction is just let 1 code. Okay. So these keras are only 1, 2, 3, 4, 5, 6, 7, 8. 8 line, 10, 11, 12. Okay. Just 12. Okay. So, alright, you can change your nasi dagang into 28 by 28. You just simply exactly follow the code. Just simply change the data set, then you run it, execute, then you got the model. Because once you can run this, then your neural network is, I think, no problem for you to explore the rest of the neural network. So I run it since okay, and let's run it again. And this is create the placeholder, okay, and this is for the training, okay. We just this is just setting. We not run it yet, okay. So this is the setting our network, and now we execute the model basically. So it's just like other function, other Python syntax. This is the way how you do it. So I put it all together in one function. So I just call this function. And now the loss is becoming low and low. Okay. And we're gonna run with that and look here basically. And so I'm gonna do the epoch 10. I'm gonna get the batch size of 100. So 100 out of 55,000. Okay. And I run it. What else? And so mini batch basically. I just divided into batches here. And I run it. Okay. The same like XOR operation. Now you can plot it basically. And where is the plotted plot? Okay. So this is the epochs. Epochs mean basically somewhere around here. Okay. Epoch complete out of number epoch loss and training phase. And okay. Epoch completed out of 10 loss, and loss is become 0.22 now. It's not really good. And you can plot, this is to plot the whole training. So this basically you don't have to do anything, just copy paste. Okay. Somebody do it, just copy paste. And you will see the number of iteration regarding the epoch. At the beginning you got loss is 0.5. It gradually up to 0. Out of 10. So the accuracy will be tens, okay? And you can run it more actually, okay? You can have, say, 20 epoch. Never mind, if you put 20 epoch, this one gonna be minimized, okay? It need to be 0.22 loss, you have accuracy about 88%. I think you need to run more epoch. That's one thing. Or what you can do is this one. First layer, 2000 neuron. Second layer, 2000 neuron. Third layer, 2000 neuron. Fourth layer, gonna be, you can try that. Okay? And you can try ReLU other thing. Even you can use your own function, replace here, and so on. Okay? And you can optimize the learning rate and all those things. Okay, guys, I think we stop here.